This conference will now be recorded.
Welcome to Red Hat OpenStack uh, version 16 demo. Today, for 1 hour, we will meet each other and we will talk about OpenStack Platform, cloud computing, what is cloud computing, and specific platform OpenStack. My name is Mohammad Ali. I am Red Hat Certified Architect, and unless that Red Hat Certified Architect, I'm certified on VMware VCP DCP, DCP version 7 and certified Kubernetes administrators. This demo has been happening through the Prodivance and COS Complete Open Source Solution. COS Complete Open Source Solution has more than 18 years experience in this market in training and certification platform. And we are uh, authorized trainer through Red Hat, Star certification, Amazon AWS, VMware, Microsoft Azure. The cost is a partner of all of them, but our specialty is on Red Hat, VMware, and AWS. Unless that one, we will run the courses behalf of the CNCF for CKA and CKS certification. Actually, Kubernetes certification in administration and security. Okay, and this is me, guys. I introduced myself. Let's jump. Okay, the first part in today's agenda will be happen on what is cloud, cloud types, what is OpenStack, OpenStack architect, OpenStack features, and I will bring the course detail into resolution. Means I will explain and I will show you what the books, how many books we need to practice, we need to review in this course with all of you. Okay, first part, what is cloud computing? If I want to explain cloud computing, and I know all of you, you know about cloud computing, but by the way, I need to start from one point, and that point is a computer at your home. The computer at home is necessary because you want to use it as a terminal for your online training. You want to use it as a entertainment device. You want to spend your time with that one for uh, daily based jobs, tasks, routines. Okay, it's mandatory. But sometimes it is not possible for all of us or most of the people to buy a powerful computer with powerful CPUs, powerful memories, powerful RAMs. Sometimes it's not possible. Most of the times we will not pay. Why we need to pay a huge money or invest huge money on a servers? What is the advantage? What the advantage? But sometimes you want this service. You want to finish your project. You need this type of machine to help you to run your project, rapidly finish your tasks, rapidly finish your job. Okay? Sometimes it's a prerequisite of the project. Then on that time we will think about it, how to arrange it. Should I borrow? Should I rent? Sometimes it happened for us for a specific project. We rented a server. Suppose, for example, we rented a server for 3 months just for a specific project to understand is it working properly or not. Now, please mute yourself. Yes, it comes to your demo. It's not. Thank you, all of you. Okay, then sometimes you will think about it. Yes, I need to. We did it for ourselves, for our projects. Either we will not invest. I want to. I've tried to show you a use case. What is advantage? Why we need? Okay, but by the way, sometimes we will do it like this. Now imagine you have access to resources. Okay, one dashboard in front of you, you have access to resources like shop. You will get inside the shop and you will ask, hey, give me two CPUs, a 4 GB RAM, 10 GB hard disk, suppose for example, and rent for 2 days. This is not actually persistently buy, and it's not going everywhere. Sit at your chair, stick on your chair, and order it. Imagine something like this. And in few seconds, your machine will be ready. And the machine gives you terminal. Hey, this is my terminal. What do you want to install? Operating system. Your project is Linux based or Microsoft based. I don't know what type of platform for operation you want. Let me know. Now your imagination is complete. Imagine you need to have powerful computer. Imagine you have access to resources and per demand. You can order, you can use, and when you don't want it, send it back. Hey, this is resources as I took from you or through you. Don't want more. Something like this. In this case, some concept will be happen. I don't want to rent a machine physically and I don't want to bring it into my home, then the concept will be happen. The concept is cloud concept, cloud computing concept. Sometimes the people they will understand or they will think cloud computing means computing on cloud. No, it's a concept, it's a title, it's a technical name. A cloud means resources accessible anytime, anywhere. Simple. Like a real cloud. Rain accessible anytime, anywhere. It depends on wind. Who will control the clouds? But water accessible anytime, anywhere through the clouds. Resources accessible anytime, anywhere through the cloud, through the platform. The name is cloud. Then cloud computing, the first concept, meaning is resources accessible anytime, anywhere. And into the meaning of cloud computing, it's a model for ubiquitous, convenient, on-demand network access to a shared pool of configurable computing resources, guys, such as servers, storages, networks, applications, and the other services. Now, if you can bring these things into one location, accessible per demand from everywhere, by everyone, congratulations, you have a cloud platform. Hope cloud computing concept is clear for everyone. Why? Because if we know the concept, we can imagine and we can have correct imagination of concepts. Okay, then cloud computing, it will allow you access resources per demand from everywhere. What resources? CPUs, memory, storage, network, and so on and so. Okay. Second one, resources can be rapidly provisioned with minimal management or service provider interaction. Second important line in computing. Imagine you have access to that resources as I told you, and I said I need one machine, one instance, the technical name is instance, and this instance with 2 GB RAM, one CPU, and 10 GB storage. And you are paying per hour, suppose for example. for example, 100 rupees per hour, for example. Okay. Now, in the mid of the project, you need more resources. They ask you, hey, this project needs 20 GB RAM because I want to expand files. I want to expand resources. We need to expand something. Then please upgrade your computer to 8 GB RAM because the resources will increase to process, and 20 GB storage because um, the file will be um, the file will be um, increased. The file will be increased, and and CPU. We need CPU, I told you, and memory, I told you, and storage, I told you. Suppose, for example, now what do you think with yourself if you have physical computer? Again, story will be happen. Again, I need to go to market. Again, I need to buy memory. If you have, good for you, but if I don't have, that is the problem. The problem will happen if I don't have. I need go and find out. I will go and find out. I need to go to market, buy the memory, add the more storage, guys, and CPU I cannot change. Maybe I have Core i3, I need to convert it to Core i7. I need to borrow, I need to talk to my father, I don't know, parents, friend, who can help me. Imagine, it's real. This is the real problem in the real scenarios. In real scenarios, we have these things. Then you will start, guys. Now, come to our cloud computing concept. I will back to my shop and I will say, hey, that 2 CPUs, please increase to 4 CPUs. Rapidly will be happen. You will put the number, and in background, it will do it for you. Rapidly provisioned. Hey, my storage till now it was 2 GB, sorry, 10 GB. Please update it, expand it to 20 GB, please. My memory RAM, it was 2 GB. Please convert it to 10 GB. Yes, please. Then, then this is advantage of rapidly provision. And you have new order. Hey, I need a storage like G drive. I want to store my information on cloud. I need I want to save my information in cloud. Then uh, I need storage like that one. I want to save my data. Maybe my storage will be, something will happen. I need to store my data in some um, object storage. The concept is object storage. Give me that one also. Do you have? Do you have in your service? Suppose yes, please. Suppose they have, and they will give you rapidly. Can sources rapidly can provision with the minimal management or service provider interaction. No need to write the mail to anyone. No need ask anyone. No need to request anyone. You can do it by yourself because you have access to that dashboard, and that dashboard inside your machine will allow you to increase. By the way, this is second one. And last one, self-service users launch instance as a virtual machines when need without required assistance from the service provider. This one is to continuing second line. When you want, start. When you don't want, stop. When you don't want at all, delete it and send back resources to the provider. Now imagine we have a model like this one, and we can manage a model like this one. This is cloud. Then in cloud, resources are available, minimum interaction with service provider, and maximum accessibility through the users. They can order whatever as they want. They can pay online. They can increase or decrease resources. It's not just sometimes for increase, guys. It's for decrease also. I want to keep my VM. I want to keep my instance, but I don't want that much resource. CPU, memory, there are much more. I don't want that much. Is it possible to reduce them and decrease my pay bill? Yes, of course, you can do it. Hope anyone has imagination of cloud. What is cloud? In this slide, just cloud. Then resources accessible everywhere through everyone. Very less connectivity with service provider. More connectivity activity through the end user to select the instance with details, to start, to stop, to change the details of that one, and billing also. Now imagine this platform accessible everywhere. Imagine this platform is existing. Do you have plan to buy a powerful or huge computers? No. I will buy normal computer. I will ask this guy to give me the access. I will order one machine for myself. I will run my project and I will delete the machine and send back resources to the provider. Simple. This is the concept. It was the concept behind cloud computing. Now, the cloud computing has been innovated. Now, today, we have cloud computing for ourselves. But the point is, how many types, what is the types of the cloud? How many clouds are accessible, available? Type number one, public cloud. In public cloud, anyone has access to this cloud. Shall I give you the sample of public cloud? AWS is a public cloud. If you want to run a cloud on your organization and you want to give access around the world to people, congratulations, you have a public cloud. Public cloud accessible through everyone, anywhere, anytime. Time and location, time zone and location doesn't matter here. Around the world, anyone has access to this type of cloud. Sometimes you said, no, this cloud is my cloud. I want to put my resources on this cloud. Yes, this is cloud, but it's not accessible by anyone unless authorized guy, authorized people, authorized resources. Then congratulations, you have private cloud. Sample, your company's cloud. This cloud is just accessible inside, not from outside. Then you have private. So many private clouds are accessible, available. And last one, hybrid cloud. You want to connect public and private together. You want to connect. You have a public cloud of your company, accessible from everywhere through anyone, and you have one private cloud inside your organization, and you want to make join between them. This is hybrid cloud, guys. Then into the concept of type, public, private, and hybrid are available here for us. Next, review this one. Public originally started applications hosting service on premises data center that include virtualization, software, and automation to build and manage infrastructure. And hybrid means config both public and private cloud resources to orchestrate together. That's it. Okay, good. What is next? The cloud computing concept is clear. The cloud types and the cloud types it's clear. We have public, private, and hybrid. Next is what type cloud models? What models are available? inside this scenario and architect. Here, as a model and type, unless public, private, and hybrid, what service you want to provide to customer. All of you heard about AWS, Amazon Web Service. In Amazon Web Service, unless as you can create a public cloud, for example, inside that one, when you get inside Amazon AWS, you are watching what type of architect they will provide to you. And we have four, but I wrote three here because one of them is a new one. It's not much new one, but it's almost new concept. Number one, infrastructure as a service. When your cloud computing says I am in IaaS level, means I am providing infrastructure as a service. Means what? Means allows the cloud consumer who wants to use the cloud to provision computing resources. Computing resources. Resources means what? CPU, memory, storage, and software, operating system, and application. Everything under your control, under your hand. You can decide about it. You can decide about it. You will decide about it. I need 2 GB memory, 2 CPUs, and 10 GB hard disk, or one operating system, Linux or Windows or RHEL or Solaris, whatever. And I want to run this type of application in top of all of them. Done. If you have this much access, this type of cloud, as you are working on it, it is IaaS, infrastructure as a service. Next level, guys, little bit down and little bit less accessibility. Number two, platform as a service. Guys, you don't have access to resource. You have access to operating system for that one. Means they will not allow you to choose hardware. Memory, CPU, RAM, everything has been selected and machine is ready, and you will come to the next level. Which one? Operating system and application or programming language. You will choose I want a Microsoft Windows and Python should install on that one. The machine is ready and you will choose it. Okay? And here we have good platform, OpenShift. It's working platform as a service. It will give you ready-made platform to run the application in a form of container. Let me explain small thing about container. Maybe you know, maybe not, but just few seconds, around 1 minute. Come out from the computing platform total and imagine you want to run an application. One computer, one application. After that, you will think with yourself, why should I use the resources of one computer to run one application for customer? Is it possible to use this computer to serve multiple customers? And the answer is yes. What is the solution? Virtualization. When you come to the virtualization, you have one computer and in top of the operating system. Guys, in virtualization, we have two main methods, bare metal and host-based. I'm talking about host-based. When you have same computer for yourself and same hardware, in top of that one you have operating system, and in top of that one you will install a specific operating system. The name is The name is hypervisor. The name is hypervisor. Specific operating system, the name is hypervisor. The hypervisor is a type of operating system who controls virtual machines. The name is hypervisor. Okay, this hypervisor, this hypervisor allows you to run the operating virtual machines for yourself. Now Now you have a virtual machines, multiple virtual machines, and run multiple applications. Guys, give me a few seconds. Okay, then now you have multiple customers because you can create multiple VMs. Okay, now imagine something better. Something better. I don't want hypervisor and I want to run the application in light mode. In VM applications, they are not in light. You need to install operating system again from 0 to 100, but it's not physical, it's virtual. You have experience on installation operating system in top of the suppose VirtualBox, Oracle VirtualBox, or VMware Workstation, or VMware ESXi, whatever. Okay, you have experience. Nothing difference in size. You need to install operating system from 0 to 100 like physical. You need to install in virtual. Then when one virtual machine will create, the size is minimum 2 GB, for example. Now you want to install, imagine you want to install application. Then this application also takes time and size and resources. Then again increase the size, 3 GB. It will make your application huge and lazy. Now, if I say we have different platform, the application in a form of container, but in this one, no need to install complete operating system. It's a customized operating system plus application as you want to run, a specific application as you want to run. And the size is not 2 GB, it's 200 megabytes. Now, what is difference between application with the size 2 GB and application with the size 200 megabytes? The difference is the application with the size 200 megabytes starts rapidly more than 2 GB. Okay? Now, in the platform as a service, we have a specific example. The name is OpenShift Platform. And in OpenShift Platform, you can run your application in a form of container. But OpenShift Platform, it is PaaS, platform as a service. They will give you platform. They will not allow you to touch resources. They will give you ready-made platform and they will ask you run your application. Watch me. They will give you platform and they will ask you right now run your application. Run your target. Don't waste your time with resources. We did it. See, this much RAM is there, this much CPU is there. By the way, then operating system, libraries, programming language for the cloud consumer will be available. You can choose. And after that, software. But when you come to software as a service, the provider provides operating system and all the software for the cloud consumers. Then, then in software as a service, the customer cannot do anything. Everything will be ready. Operating system has been installed, the application has been installed, and sit and practice for yourself. And guys, we have last one. The name is DAAS. I didn't write it here because it's not into the official list, but desktop as a service. What is desktop as a service? In desktop as a service, no IaaS, no PaaS, and no SaaS. It's a DAAS. In DAAS, we will give you one virtual desktop. What the meaning of that one? When you join to a company, they will give you laptop, for example, to use it as a terminal and desktop. Okay? They will say don't use your personal host here because this personal host is yours and you are not legal to use it for our job purpose. Then they will provide to you a machine and they will ask you, hey, this machine is yours, is limited because of these reasons, and you need to just use it for our purpose. Okay. Now imagine this computer as they have given to you, it's converted to one platform, the name is desktop as a service. Suppose Amazon AWS has one service, the name is desktop as a service. When you go to the desktop as a service, you can create one desktop plus operating system, plus suppose Microsoft Windows or Linux into this desktop. And in this time, the owner of the platform, the company, they will not say, hey, you need to run it through our laptop. Go and run it through your computer. That's it. It's a completely separate platform. You cannot communicate between your host and this platform directly. Imagine one virtual machine, but through the cloud, comes into your desktop. And through one icon, you will get access. Authentication will be happen. After that, your desktop will be open. Desktop into desktop. But this desktop is company's desktop. Okay? Then they don't want to spend money on laptop and give it to you and asks you, hey, instead of yours, use this one. They converted that machine to one new platform. The name is desktop as a service, has given to the employee. And they will ask you, run it through your desktop, home desktop, your laptop, personal laptop, doesn't matter. And in that desktop, operating system is installed, applications are installed, mail platforms installed, Office 365 installed, everything installed. Your username has been generated and they will give it to you plus authenticator and they will ask you login and use. Your mail is configured, your office plat suite is configured. That's it. But in background, it's like one real machine converted to real virtual. In this case also, you don't have access anywhere. As a user, you will log in. As a user, you will open the applications and run and operate. And after that, you will close it or log out. And desktop as a service will close till tomorrow. Again, when you go and open it. Then, unless public private hybrid, you can run through IaaS, PaaS, and SaaS, DaaS. Next, let's jump to OpenStack. Guys, how many providers are available here? So many providers available here to provide cloud computing. Red Hat is a king of open source, believe on me. You have so many applications, platforms in open source into the Red Hat. Sometimes we will say, who is virtualization master? They will say VMware. Who is open source master? We'll say Red Hat. So many platforms, Red Hat open source available inside through the Red Hat. We know just about RHEL, Red Hat Enterprise Linux, for example. But so many other platforms, open source, are available in this company. And one of them is OpenStack. The OpenStack, just for your information, has been innovated by NASA, National Aerospace in US, to make a connection between branches, and more than 150 companies are involved to create OpenStack. And it was closed source when the OpenStack has been generated. On that time, they thought we need to put resources on cloud, storages accessible on cloud. Everything should be accessible, manageable on cloud. But after that, they said, now it should be open source. And in the world, anyone should be able to use it. Anyone in the world should be able to use it. Then they made it open source, and this OpenStack has been made ready to use in the world. And right now we have openstack.org. Come here. We have openstack.org here. Google openstack.org. You have this organization who controls, who works, who manage, who innovate, and who released new OpenStack version, develop OpenStack in the world. Okay, in the world it will be work like this one, guys. I will put it in chat box for you. I know maybe you know about it or not, but once watch it, because it will give you imagination about what is OpenStack and how it works. By the way, let's come back. The OpenStack. And guys, don't forget, OpenStack is an open source community. Open source community means a community is behind the platform. I don't want to say it's not bad or it's good. I have tried. I'm explaining the concept. Here we are not judge. We just explain, and we will decide which one for us is better. In this case, this OpenStack is an open source community, and if anything happens to your platform, you need to put it on community. Now imagine, if anyone knows the answer, they will answer. If then anyone doesn't know the answer, you need to wait. Simple. Now, Red Hat has own version of OpenStack. Most of the times, OpenStack, Red Hat OpenStack, it's behind the Red Hat or behind the real OpenStack version. For example, imagine in the openstack.org, the platform is 18th, in Red Hat is 16th. Why? Means the innovative version is 18th, but Red Hat didn't release version 18th. They freshly, release version 17th, because in Red Hat platforms are bugless, complete trustable for run in enterprise business. With this reason, it's work like this one. For example, right now, suppose version 17 has been released, but inside the OpenStack, Red Hat OpenStack platform, version 16 are accessible, available, and active right now, because the OpenStack should be trustable, bugless, and important than one, uh, in background verification means someone sat inside the Red Hat, and they are supporting OpenStack for the customers who has customer for this Red Hat OpenStack. In an open source platform that uses the pooled virtual resources to build and manage private and public cloud. Okay, you know about OpenStack right now. The OpenStack is possible to run it in public and private and hybrid, guys. You can create the open means a public cloud through the OpenStack, private cloud through the OpenStack, hybrid cloud through the OpenStack. Tools tools that comprise the OpenStack platform called project handle the core cloud computing services to compute networking, storage, identity, and image services. Then, first of all, in OpenStack we have domain, and inside domain we have project. In virtualization, resources such as storage, CPU, and RAM are abstracted from the variety of vendor-specific programs and split by the hypervisor before being distributed mid. And OpenStack uses the consist set of application programming interface or APIs to abstract those virtual resources. This is OpenStack through the openstack.org, and same architect works here in Red Hat. When you come to the Red Hat OpenStack, guys, components are working together. Remember I told you multiple companies work together to create OpenStack for NASA. They didn't work in one layer. They said project by project, component by component, we will write and we will join. Just give me a few seconds. Okay, I told you, components that are working together and create OpenStack. These components are around, they are in front of you guys, and I will explain from which component um, it will be a start. If you check top one, you have component number one. The name is dashboard. When you want to work with the cloud computing platform, do you remember I told you one shop is in front of you? Imagine one dashboard is accessible. The name is dashboard. Guys, the dashboard is a name, but the project is Horizon. Don't forget. In OpenStack, we have a name for this one. The name is Horizon. It's a browser-based interface. It will allow you access access to OpenStack. Okay, that is the point of this one. Next, do you want to authenticate yourself or not? Yes, I want to authenticate myself. Okay, who will authenticate me? The name is what? The name is identity service or keystone. The technical name is identity service. Come here, number 2, identity service, keystone. Who wants to authenticate me? Who am I? How much authorized I am inside the OpenStack? Am I legal to log into the system or not? Do you have account or not? Now you have account. How much access do you have? It comes to what? Um, it comes to keystone. Okay, next one, number 3. The network is here. But if you ask me, when you come to the OpenStack, when you pass through the terminal, through the browser and authenticator, um, um, mm, it's up to you. Anything is yours. Do whatever as you want. What are you looking for? I want to run an instances, and I want to run instance. Okay. Now, if you want to run instance, you need something here. And if you check here, number 3, number 4, number 5, number 6, number 7. Suppose, for example, you need something to control network for your instance. You need something to control network for your instance. Okay, you need some storage for your instance. What type of storage you want? Block-based storage or object-based storage? A block-based storage. I need some place to install Linux. I need some place to install Microsoft Windows. I don't know what you want. Block-based storage. In Linux also, we have lsblk command, list of block device. The block device is a device as you can install operating system. Then 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 block device. Do you want G drive access to store your information backup of your hard disk? Yes. Object storage. Do you want network? Yes. Do you want something to compute all of them? Do you want something to compute all of them? This compute should be happen. Yes. They are one by one, they are here. The components, they will help you for this type of job. Suppose, for example, you want block storage. The name is Cinder. Block storage means what? Block storage means it will provide hard disk for VMs. Guys, you are not user here. You are administrator here. The user comes to you. In this level, you are not user. Don't forget. User doesn't understand, or it's not necessary to know about Cinder, compute, authenticator. No, we are administrator right now. We are watching from the top of the architect. Who connect to whom? And OpenStack is running. Who is connecting to whom? Then OpenStack is running. Imagine like this right now. Come out from the student user level. User level is done. Now we are watching from the top of the OpenStack architect. We have something to authenticate the user. The name is identity service, keystone. We need some entrance. The name is dashboard. Who will provide block storage? This guy. The name is Cinder. The Cinder provides storage for VMs. Who wants to provide something storage to save like G drive? The name is object storage. The name is object storage. And this object storage is Swift. Guys, we have multiple resources. This is default. We can change it. Swift, not object storage concept. Swift will be changed. If you don't like it, put something else. Now the user wants to install operating system on your instance inside OpenStack platform. Who will help me to bring image? Image of what? Image of operating system, image of Microsoft Windows, image of Linux, image of Solaris. The name is image storage. The name is Glance. The project name is Glance. Okay, right now my hard disk is ready, my G drive suppose is ready, my image is ready. Now I want to who will control network? This machine needs network. It's not isolated machine. It wants to communicate with the world, internally or externally, public or private or hybrid. Then neutron is a network part, software defined networking. And now guys, who wants to cook? Who wants to mix them together and create one instance for customer? The name is compute, number 5, or Nova project. Am I clear for everyone? You are watching architect of OpenStack from top. These are the piece of puzzles. The user comes, he wants or she wants to run the instance. They will come from this way. Dashboard will open. They will authenticate themselves. Where is it? Here. After that, they are inside the kitchen. They will take materials to cook the omelette. They need oil, they need butter, they need pan, they need fire or flame. They need pepper and they need salt. They are here. One of them provides hard disk for virtual machine. If the customer said, I need 2 GB hard disk, this guy will provide it. If the customer said, I need one part to back up my data, well, object storage. If the customer said, I want to install RHEL8, this one should be provided image. If the customer said, I need 2 network, 2 NICs, this one will provide. And after that, you need to put it on flame, on pan, this guy, compute, and it will cook it for you. It will manage it for you. It will generate it for you. It will happen on this compute node. The name is node. In compute node, machine will be generated. Now here, watch me guys. Block persistent storage. Store images. Guys, object storage. All are connecting to compute here. Now your customer's time is up and the instance is running. Now it's time for you, sir, guys, to telemetry. How much did you use? How much did you use orchestration platform and telemetry? How much did you use? This much you need to pay. On demand. This architect is important. Simple, but important. Because it's explaining for you, unless orchestration and telemetry, imagine number 1, to come inside the building. Inside the building, you need to authenticate yourself here in security guard. After that, you are in the kitchen. You will take this one, this one, this one, and this one, and you will ask this number 5 to compute it for you and give it to you. And after that, you will go to the cashier and you need to pay for how much did you build and cook. Simple. In operation, is not simple, guys. I'm explaining simple because I want anyone to get the point. In operation, they are not simple. We need to practice. But in explanation, so simple I'm explaining because I want anyone get the point. What is the concept? Next, OpenStack, again, overview top of that one. You have Horizon, C, web browser, or API access. After that, compute, Nova. Alternative is there? Yes, Zone. Storage, Swift, Cinder, Manila. They are not one single type. Swift as an object storage, Cinder as a block storage, and Manila as a file storage like NFS. After that, networking, Neutron, Octavia, and designate, and hardware lifecycle, Ironic and Cyborg, plus shared services, Keystone, Placement, Glance for Image. This is good concept, guys. This is good concept of OpenStack. Don't follow these types. Don't follow them. No need. I don't want you will watch them. Doesn't matter. Watch the OpenStack exactly in the meat and get the point right now. Because compute is here, storage is here, hardware is here, network is here, and who will help you to manage them? Share services here. This is for application, and this is for orchestration. The whole components are here, plus alternatives. See, Nova Zone, alternative. Next, you are watching here Red Hat projects and Red Hat products. And this is nothing unless one advertisement about how much they are powerful into this platform. This is OpenStack, CentOS, Apache, and products as it comes to this one. More than 1 million projects are there. They have like Ansible, like CoreOS, I don't know, like Quid, everything. And this is the, what is that one? This is the uh, OpenStack provisioning, how much it's provision in this one. Just a second. Just a second, guys. Okay, sorry, I just talked to Soumya because I have guys CK class also, but unfortunately, this little bit because this demo has been happened suddenly for me actually. Uh, 2 days back, they updated me. It's not organized demo. This reason, it was some confusion between classes and demo, and this reason I'm talking to Soumya. Sorry about it. Okay, then this is what this is the uh, 2018, 2019, 2022. This chart is showing you how much they will keep the OpenStack platform. Suppose, for example, in January 2018 and 2019. In this case, in this case, you have Red Hat OpenStack Platform 13 up to 2023, guys. See, but OpenStack Platform 13, guys, it is a very stable version. With the season up to 2023, they will use it. Guys, this slide is very important. This slide is very important because it will give you the imagination. Are you in the correct version for training or not? Maybe in the first look, um, it's nothing unless one chart. But where are you right now? You are in training up to OpenStack version 16. Maybe it will be happen up to 2025 and above, because the red one, they are a stable version. See, long life release 13, 16, 17. In term release 11, 12, 14, 15. Okay, guys, means you are in the correct position of training of OpenStack version 16, because it will be happen, it will support for the long time. Okay, this slide is using like this one. This is advantage of this slide, and it will decide for you. It will help to decide, are you in correct training? Should I come? Should I put my time, effort, invest? Suppose, for example. And here you are watching 13, 16, and 17. They are in the long time support to the Red Hat. Next, Red Hat OpenStack features. Guys, one feature, important feature, under cloud and over cloud, multi-stack director deployment. Uh, what is under cloud? What is over cloud? The under cloud is a one host. It has been installed by the whole components. Guys, don't imagine OpenStack you can deploy on one single host. Please. In OpenStack platform, you have one machine for compute, or maybe one server for compute, one machine for normal machine for authentication and authorization and get inside like Horizon and Keystone. You have machine for network, you have machine for storage, object, block, Manila file. Guys, each service has own host. Don't expect run all of them in one machine. It's not possible. You want to get the service to customer. How it is possible? Run everything in one machine, either one server. No, we need multiple servers to deploy OpenStack. To deploy OpenStack. Now, here to deploy the OpenStack, you need one single host. Whole components are there. The name is under cloud. It is very important. And in top of that one, you have over cloud. Under cloud means a machine with the whole installed whole components, and after that, this machine will help the others machines to install OpenStack component. With this reason, you have under cloud and over cloud. In under cloud, I told you one single machine, whole components. In over cloud, multiple machines, they will support multiple components. One machine for openness, for network, one machine for, I don't know, compute, one machine for object, one machine for block, something like this. It will be happen. Okay, then then under cloud and over cloud. Okay, we'll more practice on book and course, but don't forget this concept is there. See, you are watching here, guys. Cont- Control 1, 2, 3, compute 0, 1, and 2, or Ceph as a storage 1, 2, 3, 4, something like this. But imagine we have one powerful host, all of them, they are here inside this machine, and to this machine, the others will be generated. This is genesis of the OpenStack under cloud. And we have something here, cell support. Guys, I want to say something here before leave, because maybe you are familiar with the containerization. Before OpenStack version 13, and on version 13 and version 16, before version 13, we didn't have container. Guys, let me do one thing here, because when you come to class, this is very important. Watch me here. Here, web WhatsApp, web WhatsApp, web whiteboard. Web whiteboard. Come to web whiteboard with me. Create one board. Create one board. Okay. Now, here you have OpenStack platform, which is your platform. You have one machine, second machine, third machine. What is for Swift, for Cinder, for compute. Guys, for the first release, they were machine. Okay, they were machine, real machine. After that, they said, okay, technology has been changed. I will create one virtualization platform. Now the machines, they will come to VM, 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 VM. Okay, this is second generation. In the first part, we didn't have VMs. They put the machines beside each other and configured the services on VMs. Next, they put that machine beside each other and create platform. Next, they said, okay, the machines we cannot use hardware, come to VM. Now you have one big platform for yourself, and VMs are here again. Compute, Cinder, image, whatever. Now in the new generation, they have one single host, and they don't have VM. They have container, 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 and container. One for Swift, one for Cinder, one for image. And in OpenStack version 16 and 13 and 16, we have containerization platform. Don't forget. Okay, we don't have either virtual machine, physical we don't have, either virtual also we don't have. We have containerization platform. Then don't means in this platform we will work with the Podman, the machines, the services they happen over the on Podman and container. Next, you have here cell support, deploy and scale large scale of platform. You can deploy and scale large scale of the platform with this technology. Unique endpoint API, large clouds that need to scale if you want to scale your platform. This is API, the mix of the database and message queue, and last is compute. It will expand the number of the compute if it's necessary automatically, guys. We have two methods, HPA, VPA, but it will be happening right now. And here, high level, if you watch, advanced enterprise deployment, scale and stability, and OVN, load balancer, and basic teleco features. Guys, most of the times, telecommunications, they will use OpenStack because some features are suit for them and they will use it. And you have, this is the OpenStack till now. Next is what? Next is uh, next is course content. In the course content, guys, here for the course content, you are here for 110 and 210. Two levels are here. This is elementary and this is advanced. And this course has been designed for elementary and advanced. What do you learn in elementary and what do you learn in advanced? Stay with me here. This is elementary version 16. In elementary version 16, we will practice on will practice on managing application project, how to run instance. After that, OpenStack platform networking basic. After that, config resources, launch non-public instance. After that, virtual machines disk storage. After that, additional storage. After that, resource launch instance with the public access from outside. How to run instance to access from outside. After that, how to automate install launch the cloud applications, and after that, managing cloud application placement. This is the for CL110, what we will practice on book number 1. After that, you will jump to book number 2 here. In book number 2 version 16, here you have version 16 right now and version 16. In this one, you will practice on first advanced part. Okay, again review architect like book number one, chapter number one. Next, operating system, operating the OpenStack cloud control plane under cloud. After that, infrastructure security. After that, OpenStack user security. After that, application deployment resources. After that, storage in OpenStack, network in OpenStack, node control in OpenStack, monitoring OpenStack, and how to make automation in OpenStack. Plus troubleshooting. Troubleshooting is nothing. You cannot do most here. Just they put at some points into troubleshooting part. These two books we will practice for OpenStack. Book number one, book number one, and book number two. The book number one is CL110 and book number two is CL210. And end of the course, we will practice on question and answers. Exam orientation will happen and you will attend your exam. Means you will practice on the questions and you will attend your exam. Don't forget, OpenStack is a platform to practice. Please, it's not normal platform. You need to put your effort and you need to practice on this platform. It's a perfect platform and it's not tough. It's complicated, but it's not tough. When you get the point and overview, easily you can pass it. Means you can get the point and practice for yourself and go through. I guess we are done right now. And any query question, please unmute yourself. Ask me. I'm here to answer the query questions also about this course. If you have any query question, please.
Yeah, hi.
Hi, hi, hi.
Actually, I want to ask. See, in normal cloud like AWS, we can automatically scale up, scale down. So we can
Hmm.
do these things also here.
Yes, you can do it here also. Yes,
So,
yes, possible. No
and
problem. Hmm.
okay, okay, means the concept of cloud, whatever AWS and
Hmm.
OpenStack, both are same, but term is different.
Yes. See, we have either you can create your own cloud because right now we have cloud open source architect and deployment. Okay, then cloud right now is normal. But if you want
Mhm.
to compare in enterprise scale, if you want to compare into enterprise scale, uh, uh, when you come to into compare enterprise scale, yes, you can say yeah, correct. Suppose OpenStack as a public, private, and hybrid, but this AWS for us here right now as a public. But when you come inside, yes, the resources are. If you compare them together, see, when you are a user of AWS and OpenStack, the story is different. But we are talking about engineering of OpenStack and AWS. When you are watching through the top, yes,
Mm.
they all will support storage. They all will support memory. They all will support, suppose, compute. In AWS also you will select yes or no, memory, CPU, storage, but in
Yes.
background same technology, same concept is happening.
Okay.
Same
Okay.
technology and same concept are happening, means both are connecting to the storage, both are connecting to the network, both are connecting to the RAM, both are connecting to the CPU for compute, and they will provide it to you. Yes.
Okay, thank you. One more thing. So,
John,
what is the market demand for this OpenStack?
but listen to me. If you are looking for market demand, you can find it out in the telecommunication technology. 99%.
Okay, okay,
99% of telecommunication technologies they are using OpenStack. Now, one second. Sometimes if you suppose sometimes you want to deploy OpenShift in top of the OpenStack. Am I clear? See,
yes,
sometimes the target is not OpenStack. But you need to deploy OpenStack before deploy target platform. Okay. Suppose, for
okay,
example, your company they have planned to run the application in the form of container in OpenShift. Okay, now they said this OpenShift should be deployed in top of the OpenStack. Then OpenStack, it comes to resolution.
Mm.
Okay, sometimes
Okay.
directly you will not work with OpenStack. Sometimes directly work. We have so many companies that are supporting OpenStack. It is not issue. It's not issue. I'm talking about direct and indirect connection to OpenStack. Then
Okay. Okay.
99% telecommunication guys, they are using OpenStack as a platform. And and indirect means what? They want to deploy something in top of the OpenStack. Then again, OpenStack will come to the resolution. Means they will deploy OpenStack because of, suppose, different target.
Mm. Okay.
Suppose suddenly I finished my class with OpenStack class with Oracle. Why the Oracle needs OpenStack? The Oracle has own cloud. Yes or no? The Oracle has own
Yes.
cloud. Yes. Why they need OpenStack? Why they came to suppose us and they asked, hey Ali, teach OpenStack to them. Suppose these platforms, they asked Ali, we need OpenStack. Suppose through him. Why? Because they got project info in OpenStack. Then they
Mm-hmm.
need to run OpenStack. They need to know OpenStack. I have tried to say sometimes maybe you don't have any reason to run OpenStack. You said AWS. No,
Mm.
sometimes you have some connections. You need to, and they are not less. They are not less. So many companies, because of this reason, they are running OpenStack. But
Mm.
some companies
Okay.
directly because of job, because of business, they are running OpenStack. Yes.
Okay. Thank you. Thank you so much.
Okay. So is okay. Any other question, query?
Yes, yes. In fact,
Please.
uh, yeah, first of all, thank you for the presentation.
It's okay. It's okay, bro.
Yeah, my question is about the difference between OpenStack and container. I'm still having difficulties to distinguish between these two
Mhm.
technologies. Yeah.
Okay. Okay. I will explain. I will explain. Guys, first of all, come to the containerization. And and remember, you want to run the application in one computer. Remember, one computer, one application. After that, computers they have been changed and the VM came, and right now you have one computer and multiple VMs. Means one computer, not one single application. One computer, multiple applications. After but in VMs, in VMs, you cannot change the installation process. Means when you want to install Linux, you need to start from 0 to 100. Am I right? When you want to install Microsoft Windows, you need to start from 0 to 100. Means from the first page of the installation up to last page of the installation. Am I right for everyone? This is virtualization. It's a VM inside the host. It's a machine into machine. It's an operating system into operating system. Now, this VM is huge because when you install one VM without install any other application, it will be huge. It's around 2 GB, 3 GB. Then it's not rapid. It's not swiftly. It will not be run. Agree with everyone? Now imagine we have another platform. The name is containerization. In containerization, unless virtualization, you will not install the total operating system. You will customize your operating system, and in top of the operating system, you will put your application. Now your operating system is customized, and your application is there, but size is 200 megabytes. Then physical virtual container. Now, in OpenStack, for the first time, they put it on the physical machines. They said components on physical machine. After that, they said virtualization has been released. They said why the components should be in the physical. Suppose, for example, in physical host, let's do one thing. Let's buy a powerful server and run the components instead of the physical into which mode? Virtual mode. Am I clear for everyone? That they converted the physical host to virtual machine. After that, the containerization technology is released. They said, why we need to run virtualization? Because the virtualization is slow. We need to install full operating system. They are huge. Is it possible to run the components of the OpenStack in container instead of physical to virtual and instead of the virtual to container? Right now, OpenStack version 13 and 16, they are running the components like compute, horizon, keystone components. Instead of the physical or instead of virtual, they are running in containerization platform. Is it clear for you? You asked me this question. Could
Yes,
I
thank
clear
you.
it? Could I clear it for you? Okay, good. Any other query question? Okay. I guess Somia or Saujanya, they will back to you, and 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 we will start. I don't know what time they have planned to start. Means they will update you about timing also, and you will come and we'll practice on OpenStack platform through the Red Hat. Hope this demo was useful for everyone, and hope I could explain for everyone this platform, and um, you got the point of OpenStack and what is it, how it works, and what will you practice in OpenStack. If you don't have any query question, with respect, I will leave you, and the Somia and Sojania Madam, they will back to you for more details and timing and some other formalities of the course. Any other query question? Okay. Have a good time. Take care of yourself. Nice to meet you, talk with you in this demo, and hope again we'll meet you in course.